We began this project a long time ago about how to take into account, I mean, if you have a stratified randomization, so and you're interested in testing whether covariates or pre-treatment observable variables, they are actually balanced, how should you proceed, right? We had a real data set that motivated us to look at that. And we proposing in this paper a way to do that, which is, I mean, not new, it's actually just a reminder about how the empiricist should proceed in this case in which he or she has a stratified randomization. What we show basically here is that if you want to test for properness of your randomization, you should do or should be a little bit more careful than people typically are. So in terms of notation, X is this vector of pretreatment covariates. T is a vector of that indicates whether someone got treated or not. S is this vector of strata. So let's say that I have a bunch of strata here, and within each stratum we have a randomization, right? So we flip a coin and we're going to decide whether within that stratum someone's going to get treated or not. Y is the outcome of interest, and PS is the proportion of treated in strata S. And let's say that that might be different across strata, right? So, and we're going to discuss what kind of test people typically do when they have the same proportion or probability of being treated in all strata. And that's phi s is the size, or let's say the proportion or the importance of that stratum among all strata. So if everything has, I mean, if randomization is proper, right? So, and because randomization was implemented within each strata S, we would expect to have this in terms of mean, right? I mean, we could look at other things beyond the mean, but in terms of the mean of X should be the same between treated and control units for each strata S. So what we want to test, right, is, for example, when you look at difference in means, when you look at difference in means, you are basically looking at if the covariance between X and T, right, for a given stratum S is 0. But we want to test for the whole vector of strata, right? For every strata you want to test for that. It's not you don't want to do this separately, right? You want to do this for the entire vector. If you want to test for a vector, right, test whether this vector is 0 or not, what you should do, you should basically run regression. In terms of regression, regress X on T, dummies for the strata, right, and the interactions between the strata indicators and the treatment dummy, right? And look at what? Look at the coefficients of those interactions and test whether they're jointly equal to 0 or not, right? But that's not what people typically do, right? So what people typically do is to test whether this thing here, for the pool data, they pool all the strata, right, is 0 or not, right? But even under the null hypothesis, right, this might not necessarily be 0. So under the null hypothesis, this first component here is going to be 0, right? Because for every gamma every strata, this thing here is going to be 0. But if, for example, the probability of being treated is different across strata, right? Then there is this other component here, which might not be 0, right? So if you're doing, if you're pulling data, you have to be, it's only valid in the case that you know that there is no difference in the proportion or here in the population, right, in the probability of getting the treatment across strata. So basically, he could just do this naive thing here, right, because this thing here is going to be 0, right? But even if you do this, what's the kind of problem that you might have, right? You know that under the null, this thing here is going to be 0, right? But it might be the case that of the null, this is not 0. And why is that? Because it could mean, what we're doing here is just averaging the covariances. And this average could be such that it produces a 0 here. Suppose that in a given strata you have a positive covariance, in another one you have a negative covariance, and when you average those covariances, you're going to get a 0, right? And you're going to say, no, I have no imbalance problem in my data set when you have, right? So the problem here is, has to do with the power of the test, right? So what we say is that, I mean, you could do, if you have different probabilities here, right, of being treated, you could include fixed effect for, you could include dummies for the stratum, right? But you still would be using a test which could be, could have a small power. When you do fixed effects, and I say fixed effect is including dummies for the stratum, right? You might still have this problem of low power. So what you should do actually is to test that entire vector of being 0, because and here in the algebra is clear, because when you do the fixed effect, what you are testing is whether some average, some weighted average of this difference here is 0, right? And things could cancel out. A positive 1 for a given s could cancel out with a positive could cancel out with a negative. But when you use this Chow test, right, which is looking at the interaction coefficients, you're always getting this square here.